So hi, today we will be seeing a session on how to convert a given regular expression into an NFA with epsilon moves. So I am Nisha, and this conversion from regular expression to epsilon NFA is possible because there are theorems that has been proven, and it states that there is an equivalence between the regular expressions and the finite state machines. So let us begin. So before we start, there is a common thing which we really need to understand, that there are some standard common regular expressions which are described in the form of epsilon NFA, and the very prominent ones are mentioned here. For example, I have the epsilon NFA for the regular expression AB, epsilon NFA for the regular expression A or B, and the regular expression for, the epsilon NFA for the regular expression A star. Now these three epsilon NFAs for the respective regular expressions can be understood, and then the same shall be applied for the given regular expression together with which we produce the final epsilon NFA. So just a quick go through. So here in this regular expression A, B, we can find there is a concatenation of two input alphabets A and B. So epsilon NFA, either again epsilon NFA here, since we are speaking of the null moves or the epsilon moves in NFA, we can represent the same regular expression AB either in this pattern where there is a state change from 0 to 1 on reading A, followed by a null move 1 to 2, and then a state change from 2 to 3 on reading B. Or otherwise, simply we may make a easy transition from 0 to 1 and 1 to 2 on reading input alphabets A and B. The second one is A or B, and using epsilon NFA transition diagram, this is how it would look like. So here A or B means either the string would contain A or my string would contain B. So it is not compulsory that they occur together. It may or it may not occur. So in such case, this is how we represent the epsilon NFA. So here the starting state would be 0, and there you can see there are a series of transitions of states that is happening on reading epsilons and A, followed by we reach the final state 5. Likewise, we have another series of transitions occurring for while reading B. So for example, 0 state goes to state number 3, and it is labeled epsilon, and from state 3 it is reading an input alphabet B, which takes it to the next state 4, and from 4 it finally reaches the final state. So this is how when a given regular expression contains A or B, then we may fix this epsilon NFA model onto that particular the epsilon NFA for which we are finding for. And the third one is A star. So A star refers to the occurrence or repetition of A 0 or more times. So 0 or more times is represented using epsilon NFA in this pattern. So if it is 0 times, then we can see there is a direct arc from 0 to 3. From state 0 to state 3, we have an arc labeled epsilon, okay, which indicates that 0 is repeated 0 times, or A is repeated 0 times, and A either it might occur once. In that way, say for example, there is a transition from 0 to 1, 1 to 2 on reading a single A, and from 2 it takes us to the final state eventually. Now, what if we have more number of A's in the string? Say for example, I have A, like the 3 A's, or maybe I'll have 5 A's, or maybe some series of A's, because we know A star means A repeats 0 or many number of times. So here, for such cases, we include, okay, in epsilon NFA, we include a loop. Okay, as you can see, there is a loop from 2 to 1, okay, created by an edge labeled epsilon. And when we come across, say, 2 A's or 3 A's, say for example, from the initial state 0, it goes to 1, null move, and from 1, the first A will be read. From after the first A is read, then for the second A, 2 moves to 1 via a null move, and then again reads A. That would be my second A. And then my third A would be again, the process is repeated again. So again from a transition, there is a transition from state 2 to state 1 via epsilon, and from 1 to 2, the third A will be read, and eventually it will be taken to the final state. So these three, are the common regular expressions for which, we can actually learn how epsilon NFA can be built. And from here, we will be using them to apply and develop epsilon NFAs for any new regular expressions. So let us see examples, right? So here, for A, B the whole star, okay. Now we have an expression A, B the whole star. So just a quick review of what we learned earlier. So A, B the whole star is nothing but it is a combination of AB and the same AB being applied a clean closure. Right? So what we do is we will first construct an epsilon NFA for AB, and from AB we will create the necessary looping so that we eventually get AB the whole star. So for example, here you can see there is the epsilon NFA which accepts the string AB. Say from initial state I, it moves to a state say 1, and then stage 2 on reading A, and from state 2 to state 3 on reading B, and then finally it moves to the final state. And for the occurrence of AB, the entire string AB, 0 or more number of times, we are to introduce the clean closure epsilon NFA transition here, which is introduced here in the form that you can see there is a looping which is introduced from state 3 to state 1, and then for 0 times there is a direct arc labeled from the initial state to the final state labeled epsilon. So in this way we can apply the common expressions, right? Common regular expressions epsilon NFA onto the regular expression for which we need to find out. So another example I can show you. So for example, we have another regular expression A or B, the whole star A. Actually, you can see here there are 3 parts to this regular expression. One is the A or B part. Second would be the clean closure which is applied, the clean closure or the star operator which is being applied to the A or B string, followed by a concatenation with A. Right? So what first we do is we can draw the A or B the epsilon NFA for A or B regular expression, which is given here as such. So there are 2 ways in which A or B can be represented. Either we can use a plus symbol for A or B, or we can use a pipeline symbol for A or B. So for A or B, first we would develop a state transition diagram for NFA with epsilon moves in this pattern, where we will apply the clean closure pattern of epsilon NFA onto the A or B epsilon NFA transitions, followed by a transition for a single a transition which reads input alphabet A. So when we combine the all these regular expressions together, and we connect it with an initial state, with a single initial state and a single final state, then our work is done. The conversion is happened successfully. So let's explore the idea. Yes. So this whole part, that is starting from initial state, moving to state 1, and then we have the A. For the A or B, we have one portion here, and then this is the B, which is a series of transition occurring on the other side, and clearly stating it is A or B state transition diagram with NFA of consisting of epsilon moves, and then followed by, I'm sorry, now here so here we can see, so A or B is completed. Then a clean closure is applied to A or B. So there is an epsilon connecting the A or B, the epsilon NFA, which is drawn here, followed by a direct arc with the initial state and the intermediary final state, which was here until then. Okay, and from here we take a separate one more transition to a new state for reading the input alphabet A, and this eventually becomes our final state. So together you can see we have the A or B part, followed by a clean closure that is applied with two arcs that is labeled epsilon, and then followed by reading one input symbol A, and then leading to the final state. Now, here in this example, what happens? First, we need to identify the common portions, right? So here we have the clean closure A star directly, it is mentioned there, followed by a concatenation operation with A or B. So here A star dot A or B. So you can clearly see we can actually first, have the epsilon NFA for A star, okay, followed which I can also add on the epsilon NFA for A or B. So in this way we can develop epsilon NFAs for any given regular expressions if we are thorough with the first three commonly occurring regular expression and its epsilon NFAs. So with this I would like to thank you. We have ended the session. Yes.